So today in this video, I'll be showing you how to implement a promotion of an AP member to a CP member. So basically what happens in case of Hazelcast, the minimum number of members that has to be present in a CP subsystem is 3. So if there are less member, or let's say if one or more CP member from your CP subsystem goes down and there are less member in your CP subsystem, then your CP subsystem will not be operational. In that case, you will be required to promote your AP member that is present, one of the AP members that is present in your cluster, to a CP member. Then your CP subsystem will become operational. So all the theoretical concepts about this CP members and AP members and all other concept regarding the distributed cluster is present on the internet. Uh, there is a official Hazelcast documentation. You can just go and check the document for theoretical concepts. But in this video, I'll mainly be talking about how to implement that particular promotion. So let's get started. So I have written this small simplified program. In this code, I'll be walking you through how to promote an AP member to a CP member, and then only your CP subsystem will become operational, and your cluster can then function properly. So this is my main method, and for simplification I have kept just one class, that is HZAP2CP. In this one class only I have all the code. I've done this thing just to keep the code simple. So in this pom.xml file, as you can see, this is the version of Hazelcast that I'm currently using, 3.12.4, and I have one hazelcast.xml file, and in this XML file the number of CP members that I have defined is 3. So only if there are 3 members in the cluster, then my CP subsystem will become operational in this case. This hazelcast.xml file I have kept in my project working directory, so it will be loaded when I start any Hazelcast node. So in my main method, first of all, what I'm doing, I am creating one particular Hazelcast node. Let me open this method. In this method, what I'm doing, I'm just reading the config hazelcast.xml file and creating a config class object, and with this config object I'm initializing one Hazelcast instance, and I'm storing it in this particular instance variable. Then once my node is initialized, creating one counter. I mean, this counter is basically distributed counter. It will just make sure that I am going to add one membership listener in my code. So this counter will make sure that the membership listener will get attached to one particular member only. I mean the first member, because the first time when I'll get the value of this particular counter, its value will be 0. So the first member, the member which comes up for the first time, it will get the value as 0, and to the first Hazelcast member only, this membership listener will get registered, and then the nodes which come later on will not be able to register this particular node, because this is my membership listener. This membership listener, again, if you want to know the theoretical concepts of this membership listener, you can just go and check that Hazelcast document. Here I'll just give you a brief idea about what membership listener is. So membership listener is basically used to keep track of all the members which are coming up, or which are I mean which are going down by some reason in a particular cluster. So there's basically an event listener. After registering this event listener, I'm also adding a subscriber. So the subscriber, my subscriber class is my subscriber, and the name of the topic is my topic. Why am I using this topic? I'll be explaining it later on. First of all, I'm just showing it what all is being done in the main method. After that, I have written two methods. These methods are just for the purpose of making it clear. I mean, in these two methods, I'll just be printing the members. I mean, the Hazelcast uh, node address and their UUID. I'll just printing. Let me just open it. So in this method, what I'm doing, I'm just iterating over all the members in a particular cluster, and I'm just printing the address of that particular member and the member UUID. Similarly, in my show CP members UUID, in this method, I am iterating over all the CP members present in our cluster, and I'm just printing the address of CP member and the CP member UUID. So these two methods I have written just for the purpose of clarity. I mean, just to make things clear, so that at runtime we will be able to understand which all members were CP members and which all members are AP members. And in this example, what I'm going to do, I'm going to start 4 instances of this particular class. So what will happen, every instance will act as a particular node of a Hazelcast cluster. Every instance will initialize one Hazelcast node, and it will become uh, a single node in a particular cluster. So my cluster will eventually going to have 4 Hazelcast nodes. And then what I'm going to do, I'll just uh, terminate one of the node which will be a CP node. And then what will happen, my AP node, since I'll be starting 4 Hazelcast node, so the first 3 nodes will become the part of CP subsystem, and the fourth node will just be an AP member. So as soon as I uh, terminate one of the any of the 3 CP members, my AP member will be promoted. So how that will happen, let me just show. When I'll stop one of the CP member, this membership listener will get called, my membership listener, and in this there is this method which is called as member removed. So in this member removed, I'll get the member which got removed or terminated due to any reason. Now what I'll do, I'll just remove this particular member from the CP subsystem. So this is something which has to be done manually. I mean, till Hazelcast version 3.12, I have not used Hazelcast version greater than 3.12, so I'll not be able to say what exactly has been done in the latest versions, but till Hazelcast version 3.12, if a CP member goes down, then it is necessary for the programmer to manually remove that particular member from the CP subsystem. So if you don't remove that particular CP member from your CP subsystem, your CP subsystem may behave abruptly. So all these things are theoretical concepts. You can understand it a bit more clearly if you go through the document of Hazelcast or any of the document present on the internet. So in this method, what I'm going to do, in remove member, let me just open it. In this method, what I'm doing, I'm just getting the CP subsystem first from my instance, and then I'm getting the CP subsystem management service reference, and using this remove CP member method, I am, and in this particular method, I am passing the UUID of the member which got terminated. And since this is a future call, because this is a synchronous asynchronous method call, so I'm using this get method to, so that until and unless this member is not removed, we will not move forward, so we will wait. You can also keep some timeout in this get method. There's a overloaded get method also. If you do not want to wait infinitely, you can use that particular timeout. So in this remove method, I'm just removing that particular member which got, that particular CP member which got terminated from this CP subsystem using this Hazelcast API. There's one more thing that you can do when a member goes down. So this you will get that particular event in this method. So before removing that member, you can also check if the member which has gone down is a CP member or an AP member. So if that particular member is a CP member, then only you need to remove. If that is not a CP member, then there is no need to remove that particular member from the CP subsystem. So in this example, I have not added that particular check, but that check can also be added. But I'll show you how you can add that particular check. And in this example, I'll be crashing or I'll be terminating the CP member only. So I'm pretty sure that the member which has gone down is a CP member. So that is also the reason why I have not added that particular check. If you're doing something like this in your application, I think then it will be necessary for you to check if the member which has gone down is a CP member or an AP member. After removing my member from the CP subsystem, what I'll do, I'll simply check all the members which are present in the cluster, and I'll find one of the AP members, and so that I can promote that particular AP member to a CP member. If I do not promote an AP member to a CP member, as I said earlier, the CP system will not be operational, and all the data structures which are CP, for example, fenced lock and I semaphore, so all these data structures you won't be able to use in your application. So you will have to promote one of the AP members of your cluster to a CP member. So in this method, get member to promote, in this method, what I'm doing, I'm just getting all the members of a particular cluster, and I'm also getting all the CP members that are present in this particular cluster. Then this is basically a logic that I have written. In this logic, what I'm doing, I'm iterating over all the members. This collection of members will have the CP as well as the AP members. I mean, all members present in a particular cluster will be present inside this collection. Now inside this, now we have I've written a different for loop. In this for loop, I'm iterating over the CP members only. Now there's basically a logic of figuring out how to find an AP member which is existing in a cluster. So in this logic, the first AP member which I'll find while iterating over this all the members, I'll mark that particular AP member as a member to be promoted, right? And then I'll return the member from this method. Once I get the reference of the member of the AP member that we have to promote, now what I'll do, the promotion has to be done using the instance variable of the member that we have to promote. I mean, we cannot promote a member using any of the Hazelcast instance variable. So in a distributed environment, if you have the instance of all the members of the cluster, which I think will you will not be able to have, so there is one approach that I have implemented in this example is I'm just publishing the address of that particular member which has to be promoted to my topic, which is my topic. This is all that I have done as of now in this member removed method. Now as you can see here, initially when in the main method only, I have added subscriber on all the nodes. So the message that I published from that method will be received in this method. Now in this method, I'm doing, I'm just checking. Uh, I'm just I just got the message which has been received, and I stored it in this address variable. The member which has received this particular message, I'll get the local member object of that particular member. I'll get the address of that particular member, and I'll compare. I mean, the member which has to be promoted is present in this, the address of that member is present in this address variable, and the member which has received this data, that member address, this thing will give us that address. So I'm just comparing it, and whichever satisfies this condition, that means that member has to be promoted to a CP member. So I've written a method for that, promote AP member to CP member. Inside this method, what I'll do, I'll simply use the members instance variable, Hazelcast instance variable, and this is Hazelcast API, that is promote to CP member, and also this is also a asynchronous call. So this is how I'm going to promote my this particular AP member to a CP member. Now, as soon as I promote my AP member to a CP member, my this CP member will get added to the existing CP subsystem, and my CP subsystem will become operational after then. Now, let me also show one thing. In this remove member, there's something. Uh, Sometimes if you have some CP subsystem which you were using and there were some of the sessions which were open, so you will have to terminate, you will have to force close the sessions of that particular CP member also. But in this code, I have not opened any of the session in this example. That's why I have just commented out this code of force closing all the session of that particular CP member which has gone down. But in your case, if you need it, you can just add this code also. Okay, now let me just start this application and let me just show you how it happens. So I'll start the first instance. This is my first instance. I'll start second instance. Basically we will have to start 4 instance. So as of now I've started 3 instance. Let me just wait for all the 3 instances to create a CP subsystem. So the CP subsystem has been created with all the 3 members, and these are the 3 members. These are the addresses. Now since all the 3 members are running on the same system, so their host is same, but the ports are different. So these are the 3 members, and as you can see, the address of the CP member and the address of the AP members are same, and so is the UUID. Now let me start the fourth instance. So my fourth Hazelcast instance is getting started. Now since this is the fourth instance, this instance will be an AP instance, and the initial 3 instances were CP instances. So when I'll terminate one of the CP instance, this fourth instance will get promoted to the CP instance. As you can see here, we have 4 instances running on port 1, 2, 3, 4. So these are all the members in a cluster, and in CP subsystem you can see there are only 3 members running on port 1, 2, 3. That means this is the fourth instance which is running on port 4 is my AP instance. Now I'll simply terminate, let's say, the second instance. The second instance is a CP instance. I'll terminate that. So this is my second instance. I'll simply terminate it. And now I'll open my first instance. So let me go through the logs also. As you can see, as soon as I terminated the second instance, I got this event member gone down, and as soon as I got the event, I removed that particular CP member from my CP cluster. After removing that particular member from the CP cluster, I just found the AP member which has to be promoted to the CP member. So this is the member that has to be promoted. And as I showed you earlier, uh, the member which was running on instance 4 was an AP member. So our code has figured out correctly. It has figured out an AP member to be promoted to CP member. Now after figuring out, it will publish. So the data got received, but the data received on this node, the address of this node was different, and the data which has to be promoted was different. So nothing happened. So I'll directly go to the fourth instance and I'll show the logs. Okay, so here you can see the data received is the address present in the received data and the address of that particular local member are same. The promote AP member to CP member method got called, and as you can see, this new CP member whose address was 5704 is getting added into the CP subsystem. And after adding it, you can see that now we have three CP members in our cluster: the first, third, and the fourth one, which I recently promoted. And the second instance, which I had terminated, is not present in this particular CP subsystem now. So this is how we promote an AP member to a CP member in case a CP member goes down. So I hope this is clear to you all. There's one more thing that I would like to talk about. Let's say there are three members in your CP subsystem and all the three members go down at the same time, or maybe difference of maybe in milliseconds or something, or maybe in worst case all your three sub CP members go down. In that case, this promotion of an AP member to a CP member will not happen. You will not be able to promote. I mean, this is again theoretical concept. All these things are present in Hazelcast document. If you refer it, you will be able to find out about it. But still, I'm just explaining a bit about all this thing. This promotion of AP member to a CP member is only possible if the majority of the CP members are up and the and only a few CP member goes down. Now there is a formula of calculating the majority of CP members in a CP subsystem. That formula is also written in that particular Hazelcast document. But in case if there are three members in a CP subsystem, so the majority will be two. So the example that I have shown you, in this example, the majority was down. That is, two CP members where the majority was up, sorry, and only the one CP member gone down. So we were able to promote a CP member, to promote an AP member to a CP member. But if the majority goes down, let's say two members or three members goes down, in that case, we will not be able to promote any of the AP member to a CP member. So then one thing that we can do, we will have to restart our CP subsystem dynamically. For that, there are APIs in Hazelcast again. So this is how we can restart our CP subsystem if the majority of your CP subsystem are down. So it's very simple. You can simply use the instance get CP subsystem, get CP subsystem management service, restart, and again this is an asynchronous call. Now, one thing that has to be taken care about restarting CP subsystem is that this API restart has to be called from the parent of that particular cluster. The parent member of your Hazel class cluster will have to call this particular restart method. If any other node, which is not the parent node of your cluster, will call this method, it will not work. It will only work if the parent node of your cluster calls this particular API. This is all about promoting an AP member to a CP member in case uh, your majority of CP subsystem are up and only a few CP members goes down. Or if majority goes down or all the CP member goes down, then you will have to restart your CP subsystem. So I hope these things are the implementation is clear to you. In case if you have any doubt, you can just ask me in the comment section. I'll be answering all your questions if you have any question. So that's all for today. I hope you enjoyed watching it. Thank you for watching.